Good evening again, everyone. This is Dr. Belga Burke, faculty member at Department of CSE, AI and ML and Cybersecurity, Jain deemed to be University. Welcome all to another session of our Industry Connect program. Our guest speaker today is Ms. Haripriya Sridharan, software engineer and technical consultant. She has been associated with firms like Cognizant Technology Solutions and BangBazaar.com on many key projects. Ms. Sridharan is an expert in data analytics, business analytics, product management, strategic planning, and machine learning. Currently, she is a senior software engineer at CyberHealth. Today, she will be interacting with you on the topic PyTorch for ML. I'm really glad to welcome Ms. Haripriya Sridharan, who is a dear friend as well, to this session of our Industry Connect program, powered by Jain University and Futurance Technology. Welcome, Haripriya. Our audience today includes students of BTech and BCA AI and ML and the faculty members of the same department. So I request all the participants to turn their videos on. Haripriya, you can take over the session.
Yeah, thanks for the introduction, Belga. Thank you. Hi, everyone. As Belga has already mentioned, I am currently working as a software consultant for currently two companies right now. One is Cyber, which I'm mainly contributing. I represent from Cyber, and another company called Peppo, where I'm just consulting for few specific modules and components. So today we are going to talk about something called PyTorch for ML, right? So I've just prepared like a small PPT, and I would like this session to be more interactive. I would like more questions to be asked. On a honest note, I'm not very sure about lot of things that are going on in this department. Especially this is very fast growing, and a lot of new libraries are coming up. If today you're writing something, tomorrow you already have a library for it. So I would encourage students to talk to me and ask more questions, and please feel free to interrupt me in any case you feel like you have any doubts or concerns. So may I begin the session right now?
Yes, you can begin.
Okay, so let me quickly share my screen. Yeah, so we are now going to talk about something called PyTorch for ML. So before we begin this, I would like some insight about some insight from students about what are their knowledge on ML. So I would like to have some knowledge before I dig deep into ML or DL. So yeah, the question is open to you all. Anyone out there?
Ma'am, my name is Virat.
Yeah, hi there.
So, as per I know, machine learning is the study of algorithms that can improve our experience by the use of data and analyze it for further experience.
Okay. So have you got any hands-on, or have you got any chance to dig deep into specific machine learning or deep learning technologies?
Yeah. Actually, I dig deep into some neural language processing and some RNN stuff for language processing.
Okay. Yeah.
So I heard about the OpenAI and stuff where they translate the voices and transcribe it.
Great. Yeah, which means that most of you all are already aware, right? Let me know if you need to dig through some basics of ML as well. I can cover as part of this session. Anyone? Okay. So I'll consider that as most are pro here. So I'll talk about my understanding on this PyTorch for ML. So mostly, as we all know, this is for deep learning. But before we even talk these terms, I think someone has raised their hands. Yeah, please go ahead. Yeah, it's prediction outcomes, linear regression. That's great. Anyone out there who want to ask anything? All right. Yeah, so let me just so let's begin that, because I come from a background mostly from application development. So machine learning is something that I never understood. although like have gone through multiple courses, have gone through multiple online course, offline course. I've gone through programs, but I really did not understand how does it sit in a system. So I would like to explain this PyTorch, whatever package that we are going to use, from a system perspective. I like it more I like it to be more interactive. So I'm going to talk from a system perspective. So yeah. So the general notions, as we all know, right? So AI is more of a goal that we need to have. So AI is the goal, and ML provides more of a foundation to the goal. I'm not sure. I can hide this. Yeah. So AI is the goal here, and ML moreover provides the foundation for all the AI systems. AI is something that I would say we haven't achieved it yet. We are still in the progress, and ML is a subset of an AI. So in ML, you have concepts such as supervised and unsupervised learning. So what is DL then? There are a lot of layers to it. So let's talk a bit about what is ML, what is DL for like a brief 5 to 10 minutes before we dig into this PyTorch. So there are two concepts called supervised learning and unsupervised learning here. So supervised learning means that you talk to a system which has more control on the data and less bias. That is, it knows it can analyze a known training data set and learns algorithms that produce an inferred function to predict output values. For example, Netflix feeds. So I'm sure most of you watch Netflix. So once you watch a show, like let's say that you watch a Korean show or you watch a sci-fi show, so the next immediate recommendation that you get is basically a similar sci-fi show or a similar Korean show. How does it happen? So this one is not an unsupervised learning, but a supervised learning, meaning that this is a particular goal. The algorithm knows that this is the particular goal that it needs to target. That is, it knows that it needs to recommend something based on your input. So this is more of a supervised learning. What is unsupervised then? Unsupervised is more of like you go into a forest and you're not sure what you're going to do next, and you just look at the patterns and then figure out something and get on with the day, say. That's more of an unsupervised learning. So in terms of a real world scenario, what is unsupervised learning? One would say that to analyze our DNA patterns and understand the evolutionary biology. Okay, so humans came from apes. So to understand the pattern, you get all the DNAs of humans and then apes, and then somehow, you're not looking to analyze an evolutionary biology, but you tend to. So such is unsupervised learning. So mostly in this areas, DL is something that can that does a lot of unsupervised learning by default. ML is not great, or ML is not recommended for unsupervised learning, because supervised is something that the algorithm is learned to produce a certain output. But in deep learning, you have a lot of unsupervised learning. You're not sure what you're going to look at, so that is more of an unsupervised. So before we go a lot there, let's take an example of, let's say that sort all the fruits based on the knowledge of the fruit or its inspecting label. Say, let's say how an AI will do and how an ML would do, or how an DL would do. Let's say AI, let's think of this particular machine as an artificially intelligent machine. It looks at all the fruits, it looks at the labels of it picks it up and then drops it in a specific basket. It just reads the label and puts it in a specific basket. So the success rate here purely depends on someone correctly labeling a fruit, which is still not a great way to achieve it. Of course, as I said, we have not achieved the actual super someone. Yeah, I will answer your question on what is bias, but we will.
Haripriya, I'm sorry, may I interrupt you for a minute?
Yeah, sure.
Students, please make sure that when you post questions and comments to the speaker, it should be public. Okay, everyone should be able to see that. Please avoid posting personal questions in chat box.
All right. Thanks, Bella. So yeah, to continue. So basically, we haven't achieved such AI yet. So classifying fruits that are unlabeled is still something that AI cannot do. So there comes something called machine learning. So it is an enhanced approach of the AI that we have, which can even predict the fruits that are not labeled. So how do we do it? There is something called, there are two layers to it, which we'll be talking about in this session. One is called feature extraction, and second is called classification. So based on that, we will be deriving an output. What is feature extraction? So how would we train a machine is that we would tell the machine, hey, the fruits, these bananas always have are in yellow color. Some bananas are green in color. So we give all these data, we give colors, shape, size, and then help them classify and help them train. So based on a specific data set, it's still limited. It's still out there, but it's still limited. So what if we want to classify a fruit which the machine has never seen it at all? Let's say you feed a data of a banana. Let's say you have like a new fruit that's coming up into the system. Like say you have not trained the machine for jackfruit. How would it, how did it know if you have not labeled it and if you have not trained it like that? There comes deep learning. So one thing about deep learning is that deep learning requires a huge amount of data sets to build a prediction or to get into an output. So it requires feature extraction plus classification. But in this case, you wouldn't be actually giving a data set that would be, let's say that you don't tell them that A equals B. The network by itself will try to understand that A might be equal to B based on the set of data that we feed in. This is all a theoretical perspective on what is AI, what is ML, and what is DL, and why is DL is the future right now, and why is most models are into deep learning and not into machine learning anymore. So DL has a lot of success rate too. The success rate is close to about 76 to 80% in most of the models, while ML is not so great about that. Yeah, so how does it store and retrieve? This is something I have not gotten an idea until I really dig deep into this deep learning and then got an hands-on, especially into industries, because I'm an application developer. All I know is, okay, there is something in the system that talks to another system. One I call client, one I call server. Client talks to the server, comes back, and all that. But what is this machine learning? When we say that machine learns and gets an output, what does it even mean? How is it storing and retrieving? That was a black box for me. Especially the model part is a black box, has always been a black box for me. So let's try to draw and learn. By the way, I'll also learn as I explain. So let's try to draw and learn. So let's say that you have a system which is PC based and has good CPU. So let's talk about application development, and let's see what is the difference between this and that. You have a system and user comes into the system, types something. Let's say that in the Excel draw itself, I'm typing something. The input is fed over the web via an API or an application programming interface. Yeah. And you have a necessary output. And here the server runs, computes, and you have a database as well here, which stores and retrieves some information and gets back. Let me put it this way. Yeah, here it stores, retrieves, and gets back. That's all. That has been in a boring programming all these days, right? So it retrieves some output that we see it in the web. Sometimes the application or the it need not be the over the web all the time. So everything happens locally as well. We all know, like a local desktop application talks to itself, retrieves, and then gets back. So what really happens here in deep is that a system has its own CPU or an ALU. So the system talks to the program talks to the system in the form of bytecodes, and it retrieves some information again in the form of bytecodes and then feeds it back to the application, and then it interprets and goes over the internet. That's all that's very normal programming, or a brooding programming, I would say. And how does machine learns? When we say that, this CPU has actually learned, what does it really mean? For a long time I did not understand this. How I would like to put it into a perspective that I understood is that, let's take the same setup. Let's say there is a machine learning. Yeah, there is a machine learning platform. There is no application. There may be server, there may not be. So let's just take this out. Okay, what happens here? The user interacts with the system. The system talks to the CPU, does some programming, let's say, that's some computation, and feeds back the output. But how does it learn? What does it mean by learning? Usually what happens here in an application development, there would be libraries. The libraries, let's take a very simple known library that is being used is math library. Let's say that it computes math. Let's say that it computes some random functions, math.random. Most of you know. So when we say math.random, it gives a random value of 1 to let's say 100. So we know that it's going to give a specific output. But when we say this library has actually learned, what does it mean? So a machine learning, let me use the term library itself. Let's say that this is a machine learning library. This is a machine learning library, an advanced math, say. The same advanced math.random, let's say it is always outputting 0 once, or always outputting, let's say 10, will know that, hey, it has outputted 10 earlier, now it needs to output a very different number, maybe 20 or maybe 30. So how does it do? How does it learn? So that is where we are going to explore, and how PyTorch is used here to almost speed up the learning process is also something that we would be exploring today. I'll give a pause here. Let me know if you guys have any questions so far. Okay. I haven't seen. Okay. All right. Then I'll just move on to the next session. So we know that it is learning inside the CPU itself. How does so basically it does not store any data. It does not actually say that, hey, 10 is something that have actually given before, I need to give 20. Not really so. It gets trained over a period of time, just like how we are training a dog at home, just like how we are training our own pet, our own child from birth. That's how machine learning is also trained. So how are we training a machine? So what we do is we import the data into the machine, and then we clean up the data and make sure that, hey, this data does not have any null values, nothing of that sort. Just this is a very clean data that you can learn. Yeah, Darshan, please tell me.
I wanted to know what ALU is.
Arithmetic and logical unit.
Yeah, like a bit more details into it.
Okay.
Thank you.
Yeah, sure. Yeah, so arithmetic and logical unit is basically a computation that is used inside a CPU core or a GPU core. It does binary operations basically. So 00001 plus 00001. So that will be 00. Have you heard of binary operations before?
Yeah.
Yeah, so basically this is what it will be doing, ALU. So there might be when you must have heard terms as dual core, multi-core CPUs and all that. So when we say dual core is basically the ALU. So when we say dual core, it means that it has two cores which can do the parallel processing. So everything that we compute, everything that we type, everything that we talk basically gets into these computations. So it gets into this binary form, it computes, and that's how everything is being interpreted. ALU is like the core of everything, core of the computation. But at a time, it can perform only one operation. But that one operation can be either in nanoseconds or milliseconds, depends on how how effective is our system. Did I make sense?
Yeah, I got it. Thank you.
Yeah, thank you. All right. So yeah, let's get back here. So how do we train a machine, right? So we import the data, we clean up the data and tell, hey, there are no, this is a very good data that where you have references and you can learn. And then what you do is you allocate train data sets and test data sets. So what you do, you first train, and then just like how you train a dog, you train a dog with a ball, and then you test the dog again by saying that, hey, I'm throwing ball here, now fetch it. So you allocate mostly you allocate 80% into training and 20% into testing. That's a norm that's followed everywhere. And once the allocation is made, the next step that you do is create a model. Maybe like in terms of training a dog, you would say that you create a structure. Let's say, okay, daily morning I would be feeding you a treat, and then I would be giving you a ball. You are supposed to hand me back the ball. So this is like a structure that you set up at home. Similarly, you create a model and you build a network. So when we say creating a model, imagine a human brain. Human brain does not actually store anything at all. It's just a network. So when we say I'm looking at a watch, I'm looking at a screen itself. How do I know it's a screen? Okay, there will be neurons firing saying that, hey, there is a rectangle. Hey, it is a white screen. All these will be fired upon, and then that firing will be interpreted. Those neurons will be interpreted and then finally fed as an output to the eye, saying that, hey, it looks mostly like a screen. What do you think? And then from the old references, it will say that, okay, yeah, it's a screen that I can confirm. So that's how a model is created. Basically, there is nothing a storage or a retrieval. It's just a network. It's just like a library, but it can be trained. It can be. Am I still audible?
There is a small disturbance.
Yes, ma'am, you are audible.
Okay. Just a second. Okay.
Yeah, it's fine now. It's fine now.
Looks like my headset is not suddenly working. No issues. So yeah, that's how there is a network out there, and that network is what being interpreted, and that network can be built, and that network can be strengthened and fed into a CPU. If the CPU is always running, then we call it as an intelligent system that is looking out for that can give you result. If the system is running at one point or some other time, then we say that the model is loaded into the system and then it processes and sends the output. So basically, model is just a network or a graph, see. So once you created the model, it is not enough to just leave it there. You need to keep training the model. You need to make sure that the model is intact. I would give you one such example, face recognition. These days, face recognition is just like that. You have face recognition in the phones, you have face recognition in Instagram. So all these models are like highly trained over years of fetching the data and then processing it. It's a well-trained model that it really does not require GPU to process it. So well-trained model can stand alone in that sense. It is there even in our Android phones, to be more specific. So training a model is that important, especially with huge data sets. And then you let the model make predictions, just like you tell a child, or you make your dog let your dog make mistakes. Dog will make mistakes. The dog will initially not fetch the ball, and then you say, hey, you're not supposed to do that. You need to come back and then give me the ball. So all these are the mistakes that the dog might make. Similarly, the system would make mistakes. The system might make better prediction. The system might make wrong predictions. We'll get into deep on how to interpret and then make the system learn when it makes a wrong prediction. But making predictions is also important, even if the system is making very bad predictions. Then evaluating. So you tell them that, hey, you have predicted so many things, but you have told maybe this is utterly wrong, or maybe you say that, hey, 50% you were right, 50% you were wrong. Let's say that we tell our system to identify difference between a dog and a cat. You say, hey, you've told most of the time dog as dog, but not cat really. You told even cat as dog. So these are important, and these are important to even tell the system, tell the machine that the network is really bad. You need to work on that. You need to work on certain features. So this is how machine learning as such is fed into a system and then processed. But we are really not sure. This is still a black box at this stage. We are really not sure how do we make a model, make a network learn by itself. How do we make a network, or let's say, think of it like a graph, right? How do we make sure that there is a shortest path in the graph to get an output? How do we enhance a graph? How do we let's say in the brain itself, how do we fire quickly? That is for that, to enhance that stage of learning, we've got into deep learning concept. So there came deep learning concepts. In deep learning concepts, mostly the core of deep learning is basically mimicking human brain. But of course, it hasn't mimicked anything. It does not really work as how you think. But there are few concepts. Think of it like few neurons out here that are tightly bound, that will always give you correct result even if you change the data. So we have built something called neural network, as we said, mostly using a concept called perceptron. We'll get into that a bit later. And so mostly this was proposed at the initial stages around 1940s, if I'm not wrong. But during 1950s and 1960s, it started becoming really popular. And after that, there is this person called Jeffrey Hinton. He is a psychologist, and especially into cognitive science, and he has developed something called back propagation, with which this concept just got so popular and has started predicting outputs really better, even with unlabeled data. So let's take a big picture here. So there is an input, and there are like some hidden layers, and you have outputs. So when we say input, and when I term it as F1, F2, and F3, let's say these are features. You given the feature, you just say that, hey, cat will have a pointy ears. Dog might not really have pointy ears. Things like that you feed, and then you give all these features, and usually cats are smaller than dogs. So all these features, you actually put it as an input. And then there are some hidden layers out there, which we are not talking at this stage right now. But imagine that these features, like all these features are basically numbers that fall between 0 and 1. it can fall. Let's say that you have neurons in your hands, and when I touch something, that touch is actually a firing. So that firing will have a weightage. That firing will have a sensor. So let's say that those are inputs, and the hidden layers, whatever is the processing going on, let's talk about that later. Those are hidden layers, and there is an output, or basically the prediction that an algorithm makes, basically this deep learning logic makes. So we'll be getting a lot into mathematics right now, so bear with me. So let's get into the data science of how it works before we dig deep into PyTorch, because PyTorch really focuses on these concepts. So the input x1, x2, x3, we can also call it f1, but in programmatic terms, we generally refer a feature as x1. So each x1 will have a weightage. Basically, when I say that, there is in my hand, there is a firing that happens when I touch it, because it carries a weight. There is a heat. Something is going on here. So when I touch it, there's something new, and all these neurons will have an extra weightage. All these, but in this hand, I did not touch it. So this hand will not have its weightage. So all these inputs basically will be fed into hidden layers. I've just put one note for hidden layers. Let's just for simplification, just so that we can understand, but basically it will have millions of layers going on inside, depending on the data size and depending on the use case as well. And then it will come up with a weightage for an output that we will evaluate and then decide what's going on. So basically the same example as I said, when the touch happens, there is an activation function. So we will be, so there's something that gets computed. We call it activation function, basically the Y, or the output, ultimate output that we determine based on this activation function. Usually when this machine learning initially started, they used something called sigmoid. Sigmoid was the very old technique, which put the activation function basically into this formula, 1 by 1 plus e to the power of minus y. Minus y here is basically the activation function. Minus y is basically the output of this. So let's say that the y value is 0.5. So that will be fed into the sigmoid function. And basically this output will determine a value between 0 to 1. And because it's straightforward with one hidden layer, what if there are like thousands of layers in it? So basically we will have a summation of those layers. We put a summation here, and then we try to compute. I'll get back to the question of one of the students of what is bias. So bias is basically something that we take for each of the use case. I'll get into that later, but we add bias here, which is a whole new topic as well. So I'll get to that later. So basically we add bias here to each of the summation function of the weightage, depending on the features. So Wx plus Bi. So this will again yield a number. Everything is a number here. Everything will have, sorry, just a second. Yeah, everything will have some value between 0.5 to, everything will have some value between 0 to 1. So to make process get more simpler, what we do is, let's say that if the value falls between, below 0.5, then we take it as 0. If it is above 0.5, then we call it as 1, just so that we know, okay, it has come to some conclusion. 0 meaning that it's no way related, 1 meaning that there is something that we can consider. One popular and most widely used activation function is basically ReLU. That's mostly used right now. Sigmoid is almost cut off from most of the places. So ReLU uses another methodology. It uses a formula of like max of y comma 0. So basically, when the max of negative, so if it's close to negative, then max of negative will always yield 0. So that is something that we can always rule out. 0 meaning that there is a no match at all. And positive will yield a value. which will always be greater than 0. And we draw a graph based on that. So sigmoid mostly is not used right now, even for classification problem. ReLU is widely used, but sigmoid for some of the old use cases, for classification problem, they use it. One such example is to identify if the email is spam or not. Gmail, let's take Gmail for example. It still uses a sigmoid function to determine whether it's a spam or not. However, they have changed a lot, but this is still being used in some few very places. ReLU is mostly used for regression problem, meaning that when the data is very repetitive, and you want to determine or predict the height based on weight, age, gender. At that time, if you want to make a prediction based on the repetitive values, then ReLU is widely used. So what are we trying to determine here is we are trying to add weightages of all these hidden layers, basically here and here, and then you add a bias for each layer and try to determine the Y factor, meaning we are trying to determine a value that will again be between 0 and 1. So that we consider it as something that we can rely on. Okay, I'm going to give you one more example. So let's take a data of play, study, sleep, and the output. We basically want whether a student or someone has actually had a better day. So the student, he or she has played for 2 hours, studied for 4 hours, slept for 8 hours. So what is the output? So then we say the output is 1. That's the input that we feed it into the system. Of course, you obviously need at least lakhs of data for something to process like this. Let's say that you just put one input into this particular algorithm. What happens? So you will add weightage to each of these, and basically a single row data. In this single row data, you will compute something called loss function, and in multiple rows data, you will compute something called cost function. I'll tell you why. So for example, let's say that 2 hours, 4 hours, slept for 8 hours has resulted in something called 1, which means that the student is or the person has actually had a great day. You feed a very similar data, it will again say that 1 or 0 within a second, which means that there is a huge there's a huge black hole or a black box here that will which does not have any sufficient data to interpret. So the loss can be really high here. And how do we compute that? For a human, it is very easier for us to just say that one data is not enough to tell. But how do we tell it to a system? We tell it to a system using something called loss function. So loss function can be calculated by y minus the activation function of y to the power of square, meaning that, so when you add this y value, let's say that if it has predicted 1 and the y is supposed to be 1, 1 minus 1 is 0. 0 to the power of square is obviously 0. There is no loss at all. But with one data, the activation function will not result in 1. Obviously, the activation function will result in something called 0 or very close to 0. So without bias here, so that's where bias plays a really important role. Bias is something that we cannot actually predict or give without enough or sufficient data that is provided. We can actually let the system determine its own bias, and that can be done only when you feed more data into it. So the ultimate aim of any machine learning or any deep learning system is to reduce this loss function. As long as there is enough reduced loss, you will have an optimal output that you will get. So how do you reduce this loss function? Is basically done through backpropagation. As we said, the Jeffrey who has come up with this logic so that our loss is minimized. So what is backpropagation? Backpropagation meaning that the weightages that you give to neurons
are back propagated by computing a new weightage values. Basically, you're saying that, hey, have computed some logic, but you revisit it. You revisit the neural network. Let me add a bias here. Let me add some more derivatives here. You revisit the neural network. You revisit and tell me that, hey, what is the the new weightages for each of the networks here, and you come up with a specific output. So that's what basically backpropagation is. So how is this done is something that will take another hour to explain, but just to understand that backpropagation has its own derivatives. So basically, if you can see, it will be like so you add a lot of networks. So you will have a 3x2 matrix here. Basically, when we say 3x2 matrix, there are 3 features, and let's say that there are only 2 hidden layers, just for simplicity. And the input and the hidden layers will result in a 3x2 matrix, and the hidden layers with another hidden layer will result in a 2x1 matrix. So and then there will be an output. Let's just take this as an example. What does backpropagation here do? Backpropagation will revisit the specific node, all these nodes, by taking the old weight minus what is the derivative of the loss here and what is the derivative of the weight here. When we say derivative, we must have heard of all these integration and differentiation that's going on, right? So we will compute all these derivatives. There is a lot of math going on here. So we compute the derivative of loss and derivative of weight and minus it with the old weight. So imagine that the new weight, the new weight is basically the new weight cannot be negative. So which means the derivative of loss minus derivative of weight should be less than the old weight. So only then the new weight value will have a positive result. Otherwise, the new weight will have a negative result. How do we do this all? So basically, we plot a graph. We plot a graph and then try to figure out a local minima, they say. This is again theoretical. How do we plot a graph? How do we take data and then determine a local minima? Is basically you look at all values, you look at all loss function, and at one stage you will take a random data. You will just get into a random data there, and then you will determine in which direction I should go to get the local minimum, which means that in which direction I should go to get the minimum loss value. You will try to compute that by determining, okay, so just with the graph we can see, but using math and different other logics, you will try to determine in which direction I should move, in whether it's left or whether it's right, that is towards this side or this side. So you basically plot a graph, matplot, and a lot of other libraries, open source libraries are available. So with that, you try to determine the local minimum, and then find the point, and then you do something. You have something called gradient descent. You will try to determine the gradient descent of each of the nodes. So here, for each of the nodes, you will try to determine the gradient descent, and then you start computing things. So that's how multi-layered neural network basically works. So there is a forward propagation, there is a cost or a loss function that's determined. Again, you will do a backward propagation. So it will just go here, 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 here. So it will keep on doing this for multiple data sets, and then it will try to determine an output. So basically, you give an input, it tries to predict based on all these back and forth algorithms. To put it very simple, think of our brain itself. Our brain, we try to, so think of it like the input is fed from the visual cortex, that is in the back of the brain. So the input is, the neurons kind of fire from the back of the head to the front to interpret the data, and then again it goes back to the back of the head, tries to determine whether the output really matches with the features that are inputted, then again goes front and back, and then tries to find a local minimum. That is, when the loss is really less, then you will have an output, and that is predicted and given back to the system. So yeah, So what we are trying to achieve in each of the deep learning framework is that it has to be almost equal to 0, which we have never achieved in any of the networks. But usually the prediction will be close to between 70 to 80, that we call it as a really good 70 to 80% of the time you get closer to 0. That it was, I mean, that is what it means. So that we call it as a good model as of now in our current market. Yeah, so this is a forward and backward propagation. Let me stop here, and then I'll be open for any questions, or in case if you want me to move forward, I can move. Okay, so what PyTorch really plays a role here, right? So PyTorch is a deep learning framework. So basically, again, think of it like a library that supports the framework for deep learning. So it's the code is actually written in C, and it's generally used via Lua interface. So there was something called Torch that was written in C, and then it was using a Lua interface. Lua is a different programming language altogether, but we couldn't actually use that package to interpret in our current ML scripts. So the team actually developed something called PyTorch. They gave the same name as Torch because they took the concepts from the deep learning C framework, and they developed it in Python. So what is it mostly used for? NLP, computer vision, audio data, and everything. And the training process requires that you define a loss function. It's you who define it. You tell that, hey, when I give you a data, when the function is this much, then it's considered as loss. So you define the loss function and the optimization algorithm in the PyTorch. So some of the some of the loss functions that are widely used is cross entropy loss for categorical loss and multi-class classification. And there is a training model that involves enumerating the data loader, meaning that so you give a data set, you give a CSV basically, and then the training model involves enumerating it. It looks at a pattern and then tells, put everything as 0 here because it's all the same, put everything as 0.1 here, maybe like that. It enumerates each of the data sets or the training data sets here. Basically what it does is looks at the code and then by hearts it. So before we get into these advantages of PyTorch, I would like to give a small I would like to show a small demo on how the model and the prediction really works for someone who has not tried programming before. So yeah, I'm here using Jupyter Notebook just for my own. This is my favorite, and this is something that I have used most of the time. Other than VS Code, I can show the outputs then and there as I write. So it's a line by line execution and something that is very easier to interpret as well. So there is a model that let's try to develop, which is called music recommendation model. There is a CSV file that's already present. If you look at the CSV file, it's got very simple data. We are just loading 19 rows or approximately 20 rows with one header. So it just got gender, genre, and age. We are saying that for the age group, for the age group between this much, and let's say gender 1 is male and gender 0 is female. Gender 1 likes genre, hip hop, jazz, and classical, and these are the age groups. So that's the data set that we are feeding into it. How do we develop a model? So the first and important thing is to do a model selection. So sklearn is very popular here in that, and we use pandas. Pandas is mainly used for plotting and data interpretation as well. So before we dig deep into this PyTorch of it, I would like to show one simple demo of how it's done, how a model is loaded, and then how his model is built and then loaded into a system. So yeah, this is how model is made. Basically, there is an sk.models you select, and sklearn has something called model selection, with which you can actually frame. It randomly splits data between training and testing. So in this line, if you see, you give x underscore train test, y underscore train and test, and you tell them that, hey, split between x and y, and keep the test size to 0.2, meaning that keep 20% as test size. And then you tell them that, you are using this classifier. Here you are using a specific classifier called decision tree classifier. That is the model basically that you are using, and you are trying to fit that classifier into X train and then Y train, and you are trying to make a prediction here. So this is like already built one. So if you look at another example, here you are using the same decision tree classifier. Yeah, I've just commented this code. Here you are using the same decision tree classifier, fitting into it, framing a model. Usually the model files are pickle files or joblib files. So you have, so I've just created a joblib called music recommender.joblib, and then you ask it to predict, hey, what if there is an age group? So basically, if you see, it has, you are dropping something called, you're dropping something called genre, and you are actually doing a data frame based on genre, meaning that based on this, it will try to interpret the data of age and gender and give you a result. Meaning this line model.predict will say, hey, for the age group 21 male, what is the likely genre that would be preferred? And it's hip hop. Of course, it's not always true, and it's very minimal data set. So this model is not something that is so great, or is not something that is well trained. Just gives an output based on what it is trained. But what is so special about machine learning? This can be done by any library itself. What is so special about machine learning is that this can be trained. I mean, if I give more output and train the model here, I will get better predictions. So I also try to, I also try to put a graph. You can also, I may not show all of this right now because it's not related to PyTorch, but there are a few libraries that can actually support the graphical view of a data as well. Here I have used GraphViz. There is also line that has, that does not give visualization, but a lot of interpretation of how the decision is made can also be seen. So yeah, this is about, this is how programmatically you will load a model and you will ask a model to predict. Let's get into this PyTorch neural network, right? So how it's done? So basically you need to install something called Torch. So Torch is the library, Python library that is used for deep learning networks, and then have imported, it's already installed. I'm importing Torch, I'm checking the version. So it clearly says that it's 1.11.0 and CPU, which means that this Torch is not GPU based. It uses mostly CPU here, and it's installed in the CPU. It can also be checked via this command, NVIDIA and semi. Basically, I'm using a GPU-based system, but I'm installing Torch that will compute on CPU and not GPU. There is no GPU involved right now. So there is also CUDA framework that supports, GPU-based processing, and this will help you identify whether it, whether the CUDA is available for the Torch, and basically not, so we can ignore it. And so this example we'll try to just check. Let me expand this. In this example, we'll just try to check how a basic PyTorch is being used. We use something called Tensors. Again, it's a NumPy based multi-dimensional. Yeah, there is a chat. CUDA is mostly for NVIDIA. AMD, no. CUDA is mostly for NVIDIA. Supports well in NVIDIA. It can be used for AMD, but there are a lot of other configurations that you need to do for an AMD. Yeah. So just a second. Good. Yeah. So let me just check if my video is okay. Yeah. Am I still audible?
Yes,
Yes.
ma'am.
Yeah. Okay. Thank you. Yes. So we will just quickly look at how this NumPy framework, NumPy is being used. So NumPy is basically used for arrays, used for arrays and computing arrays. But what does Tensor do here is Tensor will help you frame a multi-dimensional data set. So the reason why I wanted to show you this is we talked a lot about a lot of things going on here. Hidden layers, there are weightages and things like that. So all these are computed. So all these are computed basically in the matrix form. You have everything by the end of the day will be talking to each. Every computations will happen only through matrices. So everything will be tensor. By the end of the day, it will have a lot of tensors and a lot of multiplications that will be going on. Matrix multiplications, especially because you can have multi-dimensional computation, as we are talking about millions of data getting interpreted. So tensors help in that area. So tensors here, what you will do is, so you have torch from NumPy and you load it in an array. And if you try to print the tensor, it will tell you what torch.n32, meaning that it will tell you what is the type of the data type that is available in the array. Basically, it is a one-dimensional right now. So it has a one-dimensional output. So this has got other interesting functionalities as 0:2, meaning that you try to only extract the first two elements from the array. And when you try to print it, it prints 3, 4. Similarly, if you want to take, from 1 to 4, so you give, you give 1:4, and then you get 4, 5, 6. And it is still the integer 32. So what is the disadvantage from NumPy is that, so if the tensors, let's say that we are overriding this, there is an array variable here, and we have used NumPy array list for this, and we have also used imported the same array in this tensors. And if I change the tensor, let's say that I'm changing the fourth value of array here to 100. What happens to the actual array variable which got copied? That also got changed, meaning that let me try to open yeah. So meaning that when we were talking about CPU, ALU, and all that. So here in memory, usually the data is linked. So if one changes, the link also gets copied, and if like let's say we say A equals B, if A changes, B also changes. So this is not a shallow copy, it's tightly bound. So that is one disadvantage of using NumPy. But to overcome that, to overcome all these problems, what you can do is we can say that do a shallow copy. So instead of actually doing torch from NumPy, you can say torch from tensor. So tensor in that sense, it creates a shallow copy of this. If we say A equals B, it will say A equals B. It will say A equals B equals C. So it will put everything in the C and refers from there. So if A is changed, B is not changed. So such shallow copying can be achieved in Torch using tensors. So that's one advantage of tensors, and it's very important when it comes to deep learning and when it comes to especially the usage of PyTorch, because that mostly relies not on NumPy but on tensors. Yeah, so that's one. And Torch also has a lot of other interesting inbuilt libraries. Like if you just say torch.zeros and you say that, hey, it is going to be a 2x3 matrix, meaning that there will be 2 rows and 3 columns, and it's of type integer 32. Let's say that you type this, and if you try to print, it will create all these 2x3 dimensions with everything appended as 0. You can actually also do ones here. So let's say I'm executing this. All these will be 1 of type integer. So there are, and you can also do a lot of arithmetic operations. Let's say that you have like 2 arrays here, and if you want to do an arithmetic addition of these 2 arrays, simply what you do is you just say torch.add a comma b. It adds all these 2-dimensional arrays and prints you the output. Similarly, you have a lot of advantage of using it, and it can also be used for multi-dimensional array adding too. I think we have crossed 1 hour. May I take more 5 minutes, Belga?
Yeah, you can take 5 more minutes, no problem.
Yeah, thanks, Bella. Okay, so I'll quickly wrap up. So basically, PyTorch, I have just created one example for diabetic prediction. So in this, I have used PyTorch library, and we are trying to predict with the given data set, we are trying to predict whether the person has diabetes or not. So let's say that you have, so I have taken this diabetes.csv basically from a site called Kaggle. It is widely used for, they have a lot of variety data sets, and they have, especially for health sector, they have a lot of different data sets. I have taken one for diabetes. It has, if you try to print head, it has these values. So as we said, the first step is importing data. The second step is cleaning it. If it's null, and if it's null, then sum it up. We are saying no, it's not null, and the data set is clean and everything is proper. And then this CBON is something that you can ignore. I've just put it saying that, so there is an outcome. Basically, we are feeding the data set and saying that, hey, if this is the value, then the outcome is 1, meaning that they are diabetic. So based on the outcome, that is hue, pair the plot. Even there is the SNS library that helps you pair the plot and then gives you a variety of results. That's one. So what here you're doing is you are doing a model selection as usual, and then you try to split the data randomly into some percent into training and some percent into testing based on the outcome. So because outcome is the key factor here, you are trying to drop it from the X and then you are putting it in Y. So if you try to print the X, these are the values. And if you try to print the Y, all these outcomes are bundled up into an array. So it's a one-dimensional array mostly. So here, as we just saw earlier, we are using these train and test, and then try to set the test size to 20% and the random state to 0. We are saying this may not be any random. And then, so what are the libraries that are mainly used for torches? We use Torch. Torch.nn as one as for computing the neural network. And then there's functional F that we will see at a later stage. So how do you create tensors? Basically, you say that X train test and Y train test are all based on float values. This is very important when it comes to PyTorch again, because everything needs to be in float in order for it to compute the values. It cannot have a numerical integer, because you are trying to make this prediction based on none of the defined features. You're just saying that, hey, these are the values, try to give me an output. So all these training will have a tensor array of float. So that's one key feature of PyTorch. And if you try to shape it up, basically you have 768 rows and 9 columns here. So this is an artificially intelligent, artificial neural network, which is actually more similar to multidimensional neural network. Here I'm creating a class for it and saying that, hey, my input has, as we saw it earlier in this PPT. Let me try to. This input here is it has 8 features, and the first hidden layers has like 20 features. Second hidden layer has 20 features, and output will have 2 features in it. So that's the kind of ANN that we are initializing, and then we are connecting we are just defining F connected 1. Basically, we are trying to connect these layers. We are saying, hey, connect input and hidden. Then we are saying, hey, connect hidden 1 and hidden 2. That's special. That's mainly why we are using this connection. And similarly, we are saying, hey, for the linear thing, try to merge hidden 2 and out, and then give me a result. And f.relu, f is basically this one, is basically the activation part that we talked about, the activation function. Here we are using relu activation function, and we are trying to determine based on a value, based on any data set. It treats a data and then it computes and gives you an output. We are not worried about how it does in terms of programming, but it computes and gives you an output. So here you are in this, you are basically doing a manual seed of 20, and then you are assigning it to you're creating a model. Here I've just defined it. Here you're creating the model. And then if you look at the model parameters, these are the things it defines. And you are trying to compute a loss function. So I'm using cross entropy loss here. So again, this is not something that we need to define for a PyTorch because it's already out there, but it is important to give a loss value. 0.01 is something that I can bear, not anything below that or not anything beyond that. So, anything below that is okay, nothing beyond that. So we cannot give 0 as loss function. So we have given 0.01. So here, so these are the definitions. These are something that we just saw in the PPT. We just saw how these hidden layers are basically defined. So how does the model make the prediction? So this is the main logic. Basically, for the epochs 500, for all the initial 500 data set, for every 10 rows, just print the epoch number. Like what is the number that you have determined, the final number that you have determined, and what is the loss when computing that particular row. So this is something that we are printing. And we are zero grading the optimizers, meaning that none of if the grade level is 0, then we are just cleaning that up, and we are doing a backward propagation here. So I'll explain you what these 3 things are in quickly in 2 minutes. So basically that is what we are doing, and then we are trying to plot it out. And if we try to plot it out, mostly we are using the confusion matrix to to determine the rows and columns. And here we are using the MATLAB plot to figure it out, to plot a figure from the actual values versus the predicted values. And we are saying annotation is not required. So so once the model is developed, you quickly save the model. Usually the model files are .pt. It could be anything, .job, a lot of other things as well. So, but basically you save it as diabetes.pt here. So the model is developed, the model is done there, the network is set up. Now you are evaluating a model by giving an input. Basically, you are feeding this input 148, that is pregnancy, glucose, blood pressure level, all is this. Give me a value to determine whether this particular patient data of age 45 basically has diabetes or not. It says 1, which means they might have diabetes. Not really they have, but 70 to 80% probability is that they have diabetes. So that's a quick wrap of how this PyTorch is used. So I'll not dig further here. So basically, the three lines that we saw: optimizer.zeroGrad and optimizer.step and loss.backward. Loss.backward is the back propagation, and this update model, this optimizer.step is basically to update the model. This is a very important step. This is the step that will actually rearrange the neural network. So this is why this is used even in ML. So this is important in DL, and PyTorch makes it done in a very simple form. Yeah, that's it from my end. Any questions?
Ma'am, I have one question.
Yeah, please.
Ma'am, like you said, you train your model. Like, what are the specifications of your system to train a very good model? Like, can we train our model on our laptops and stuff?
Yes. So currently I'm running this on a laptop. If you have a good GPU, then you can train it. So ML does not require you to have a CPU. So training a model can even be done with a laptop, which has a good at least a good dual core CPU in it. And if you have GPU in your laptop, basically if you run this NVIDIA, and I have an NVIDIA based GPU laptop. If you run this code NVIDIA-SMI, it will tell you what is the CUDA versions and what is the GPU that you're using and all the specifications. This is good enough for you to actually. I'm using NVIDIA GPU. So this is good enough for you to actually run a model. You can run it in mostly in any laptop. If you have noticed, in cryptography, crypto mining and all is done on CPUs itself. That also has a lot of ML models going on, and it can technically be run in a laptop itself.
Ma'am, like deep learning models take the ton of GPU to process and train the models. It takes usually days, but I don't know like if we can write a deep learning model on our laptops.
We can. Technically, training requires GPU. Basically, if you have huge data sets, then if you want to, like say millions of data set, and if you can actually support your laptop with good fan and keep it running for a day, you can do it on your laptop itself. Does not really require an AWS GPU machine for you to train it. As long as you have laptop with good GPU, you can keep it on and then train it. Yes, Darshan, please tell me.
What are the limitations for an AMD processor in comparison to NVIDIA when it comes to these processors?
Basically, the core is GPU core is what the limitation is. AMD is still on. I mean, AMD is good for. So to talk about specific limitations, basically the dual cores and yeah, I'm really not sure about the specific cores that are present in AMD, but generally NVIDIA has better GPU for computation. So AMD hasn't gone into that level. AMD is still cheaper. AMD is still available in mostly in a lot of markets, and that is also a disadvantage because that does not have a core GPU. It's good for programming. It's good for local programming, application development, and everything, and not for deep learning.
Ma'am, I have another question.
Yeah.
There are many deep learning or training models available on GitHub. Like, do you have to train them, or they are already trained, or do you have to fork them and then train them?
That depends again. So you need to most are already trained. If you have a model out there in GitHub, mostly they are trained. But you need to also download the model. First, ask it to make predictions with your data and see whether it's making a good prediction. If you think that it is not making a good prediction, then you can always go to this Kaggle, download enough data sets, and then do a training on top of it. But most models are trained when it's published in GitHub and it has a lot of viewers. lot of commits and everything, usually it is screened.
Thank you, ma'am.
Yeah, thank you.
Haripriya, there is a question in the chat box from Athar.
Yeah, sure. Yeah, which is the better framework for working with neural networks, PyTorch or TensorFlow? Yeah, so choosing between PyTorch or TensorFlow depends on what type of the problem are you trying to determine. So there's this, I talked about classification problem and regression problem. If you are going for a classification problem, then sigmoid functions are popularly used, and TensorFlows are also used along with that. But for regression problems these days, PyTorch is greatly used. And one advantage of PyTorch is that it's comparatively lightweight and uses the GPU effectively than TensorFlows. So PyTorch is actually widely, it's getting more popular, and you have a lot of people working on PyTorch to optimize it. So yeah. So neural networks, especially for my ANN and for CNN, PyTorch is used. Maybe for MNN, multidimensional, there are still TensorFlow can do a better job for that. Yeah. Yeah, thanks, Abhi.
So if you don't have more questions, shall we wind up?
Yeah, sure, Brenda. Thank you.
Yeah. Okay. So thanks for the brilliant session, Haripriya. So I thank Department of Computer Science Engineering, AI/ML and Cybersecurity and Futurance Technologies for organizing these Industry Connect sessions for our students. We are grateful to our resource person, Ms. Haripriya Sridharan, for accepting our invitation to conduct this session for the students. Thanks are due to Dr. V. Vivek, the head of the Department of Computer Science Engineering in Artificial Intelligence and Machine Learning and Cybersecurity, and the team of our faculty members for the support they offer to provide the best to our students. Thank you, students, for participating in the session. I am posting the survey link once again. You can just fill it before you leave. I think we can call it a day then. See you all next week. Good night, everyone.
Yeah, thank you so much. Thanks.
Thank you, ma'am.
Thank you, everyone.